in the range negative 90 degrees to 90 degrees, how many values of x are there for which the sum to infinity of 1 over tan x plus 1 over tan squared x plus 1 over tan cubed x and so on equals tan x? Right. So my first instinct here is that this infinite series that's given to us looks like a geometric series. And so I should be able to write what that is equal to. It looks like an infinite geometric series, but we have to be a little bit careful about when it actually converges for which values of x, right? If tan x is less than 1, then this thing doesn't actually converge. But let's worry about that a little bit later. Okay, so I have, let's let y be equal to tan x. So then I have 1 over y plus 1 over y squared plus 1 over y cubed plus and so on. So this should be equal to a over 1 minus r. Now this is just me memorizing the formula for infinite series, where a is the first term in the series, 1 over y, and r is the common ratio, which is also 1 over y, 1 minus 1 over y. So this is equal to 1 over y divided by y minus 1 over y. And so I get 1 over y minus 1. Okay, so this only applies when y is in absolute value has to be greater than 1. Right, you need the common ratio r to be less than 1, and that says that the absolute value of y is greater than 1. So tan x in absolute value is greater than 1. So we'll keep that in mind. Okay, and so we're told we want this to be equal to tan of x. So we're looking for when y is equal to 1 over y minus 1. If I rearrange this, y squared minus y minus 1 is equal to 0. Should I just use quadratic formula to solve this? Well, no, I see that y is equal to 2 is a solution, right? 2 squared minus, oh, no it's not. No it's not. Let's just write the quadratic formula. So y is equal to 1 plus or minus the square root. Is this the golden ratio? I never remember exactly what that expression is. So 1 plus or minus root 5 over 2. Okay. Now I happen to know for the positive root, y is equal to 1 plus root 5 over 2. This number is, what is that, about 1.6 something? But the other one, y is equal to 1 minus root 5 over 2. This is negative, but let's call these y1 and y2. The absolute value of y2 is less than 1. So we can't use that in our solution. Okay. So we're looking for values of tan x, which equals 1 plus root 5 over 2. And what does the graph of tan x look like between, it has vertical asymptotes at 90 degrees. I don't like that they wrote it with degrees rather than radians, but okay. Something like that. And so we want, at 45 degrees, this value here, that's equal to 1 at 45 degrees. So, I think the answer is 1 because there's going to be some value here where it passes through the golden ratio. Let's just, mark what we want here. I don't think any other values are going to work. At least it doesn't. Let me just check some of the logic in my head here. This only converges when y is greater than 1 in absolute value, and it's equal to this. So we need these things to be equal. Right? Y is equal to -1 plus or minus square root of minus. Yeah. Yeah, I'm pretty sure that this number has absolute value less than 1, right? 1 minus root 5 over 2. Root 5 is approximately, it's a little bit more than 2. So this is, approximately 1 minus 2 point, 2 point x divided by 2. So this number has absolute value less than 2. And when we divide by 2, it has absolute value less than 1. So yeah, that root doesn't count. Because for this value of y, the series doesn't converge. Yeah, I'm happy with this. So, I'm saying that the answer is B, that there's only one value of x that works here. But I'll let you know if I have a mistake. I'll highlight it somewhere in the video. But I'm not sure where my logic will have gone wrong if this isn't the correct answer. Thanks for watching.